Hello, my name is Hamid and I'm from Tripoli 23 batch. Our task was to build the project named Password Protected LED system with LCD display. Basically, the system allows access control using a 3-digit password. A user can input the password using buttons and the system verifies it. Based on the result, the LED indicates success or failure, meaning password is correct or wrong, and then all system states are also displayed in the LCD. This is our basic introduction of our project. So if I want to talk about the working principle, initially there is a LCD display. I think I have to first talk about the circuit diagram and circuit connection. First of all, we have a LCD display there and we connected the ground to the ground pin. We use a breadboard and we connected the power rail negative and positive to the Arduino ground and the Arduino ground. And we know that if there is connected a I2C module to the LCD display, then they are 12 or 16 pin reduced into 4 pin ground, VCC, and serial data and clock line. So serial clock. So ground is connected to the ground and VCC is connected to the 5 volt, and SDA or serial data is connected to the F4, and SLC is connected to the F5 of the Arduino. Then we use 4 push button. It is the confirmation push button and it is for 3-digit input. Every push button have 2 sides, positive and the negative. The negative of particular push button is connected to the ground pin, and the positive button is connected to the digital pin or digital input output pin of the Arduino board. Like this push button is connected to the 3, and this push button is connected to the 4, 5, and this is connected to the 13. And we use there are 3 LEDs for 3 separate purpose. This is the LED for the confirmation, this is the LED for the error password, and this is the LED for indicate the lock. The system is locked after 3 wrong password. So each LED has anode and the cathode. Anode is the positive terminal and cathode is the negative terminal. So anode is connected via a 220 ohm resistor to the 9, 10 and 11 respective LED to the digital pin of the Arduino board, and the negative or cathode part is connected to the ground terminal. So this is the basic our circuit diagram of our project. So if I want to tell the working principle, initially the LCD show I have to start the simulation. Initially the LCD, this is called the LCD display. The LCD display show the enter password and there is 3 placeholder. There are the 3 push button for entering digit from 0 to 9, and one of the features of this project is that the button can take the digit from 0 to 9 and after 9 it starts again from 0, which is similar to the real world system and very user friendly. If I want to give example, 1, 2, we increase to 9 and then again 0. This is one of our key feature. And there is a confirmation button. This is the confirmation button which is separated from this 3 push button. Confirmation button which is used to confirm the item or password. The system compares the entire password with the stored password or the predefined password. So if the password correct, I set the password 1, 2, 3. So we will upload 1, 2, 3. So in the first digit 1, second digit 2, and third digit 3. Then when we press the confirmation button, it will show the message welcome, correct password, and the green light is on for 1 second. If I show again 1, 2 and 3 and press the confirmation button, then green light is on for our 1 second, and a message will show in the LCD which is complete our requirement. And if we press any wrong digit like 1, 1 and 2 and press the confirmation button to enter the password, the red LED blink for the 3 times, and there show a message 1, 2, 1 wrong password and attempt 2, because I entered the password for the 3 times. So red LED blinks for the 3 times and LCD show the error and the attempt count. And after 3 wrong password, if I press another 1, 1, 1 and 1 and press the confirmation button, red LED blink and our item is 3 times, then our system will lock. System locked, wait for 5 seconds, and our lock LED will blink, will on for 1 or 2 seconds, and a message will show. So after 3 wrong password, system enters lock state and lock LED is turns on. then system reset automatically after 5 seconds. You can see that system is our reset after 5 seconds of the lock state. So we use separate LED for the success. This is green LED for the success when we press the right password 1, 2 and 3 and the confirmation button, then green LED is on, and when we press any wrong password then our and press the confirm, then our red LED or error LED can blink for the 3 times, which makes the system more realistic or real world experience. So if I want to talk about the key features of this project is if we input 2 wrong password like 1 and confirmation button, wrong password attempt 2, but then if we upload the correct password like 1, 2 and 3 and confirmation button will come as usual, but then our attempt will count from the previous, means when we input 2 wrong password, then if we press the correct password, the attempt counter will reset to the 0 as usual, which is very realistic and user friendly. So as I mentioned earlier, the green LED is blink for the correct password, and the red LED, this red LED is blink for 3 times for the each wrong attempts, and the lock LED will on for the lock system. So in code I want to show one thing which is very user friendly, I hope, because if we want to change the password, like we just have to change the set space variable, like I said the password 123, and if you want to change this password, like I have to stop the simulation. So if you want to change the password, like just press just correct there, and nothing more you have to do in entire code. So just change the set password, which is predefined password 111, and if we start the simulation again, this takes 1 second, yeah, then 1 and confirmation button, welcome password, which is also very helpful because we don't change the entire code system or any other anywhere of the code. We just have to change in a set password variable, the password will change, predefined password will change. And also one thing is if we hold the push button, then the digit will increase from 0 to 9, and again from 0 to 9, means a loop will created, which is realistic and implemented in the real world also. And when we enter 3 incorrect password, like first attempt, second attempt and the third attempt, then system will lock for the 5 seconds. We know that system lock, wait for 5 seconds, and the lock LED will be on. But after 5 seconds, the whole system will reset to the 0. Again, we want to put the wrong password, then attempt will count from the 1, which is also a key features of this project. So in this password based system we can use in our real world, such as ATM machine or the mobile phone screen, app lock, digital door lock, locker, and access control system in the restricted area. In such case we can use this whole project. So I have to explain the code, and first of all we include the wire.h and the liquid crystal IC2 header file, because we use the I2C module for the LCD display, and we create a object. This is the class and this is the object, and 0 cross 27 is the address of the LCD display, 16 is the 16 row, and 12 column. And there are all the variables there. I comment out what are those, like there's count 1, count 2, count 3, count a, locked, and set space. Set space is our predefined password. In the void setup, LCD initialize the LCD display, this line, and this line on the backlight of the LCD display. And in the pin mode, we defined the input pull up for the push button and output for the LEDs, 3 LED, and we set the LCD set cursor mean we put we set the cursor in the LCD display where it will be. There is the column and row, and the LCD print is print whatever you want to the LCD display. And again we just write this to enter password and the placeholder. And in the main loop, if the locked is equal to 1, means when the system is locked, block everything. Lock system lock system, it will refer to the lock system function, and then if it is lock system, then return all. That means that it will not execute the whole code, just return, just come out from the loop. And there is a digit 1, digit 2, digit 3 function. Integer b is a variable to check the confirmation button. Digital bit from 13, we set the confirmation button to 13, and if b is equal to 0, that means that if b is pressed, the LCD, first of all, lcd.clear is to clear the whole scheme. Then integer entire is a variable which is in where we set the password, we store the password, like we separate each digit of the set password. And if entered is equal to set password, means that whatever digit we entered is if it is equal to the set password, correct password function will override and count will equal to 0. That means that atom will be 0, reset the wrong password counter. And if else means if the entire password is not same as the set password, then incorrect password function will be executed, and count 1 means atom counter will increase. And if count is equal to 3 times, that means that we input 3 wrong incorrect password, then the locked 1 is equal to 1. That means that our lock 1, when lock is 1, then lock system will execute, and whole function will not be execute after the return option. And delay for 1000 means delay for 1 second, and reset for every execution. And while a digital write equal to 03 means that wait the button to release, not to the whole, to prevent the continuous increment or such kind of holding problem of the confirmation button. So void digit 1 is a function, and void digit 1, void digit 2, and void digit 3 all are 3 same. In A we defined a variable where we read the state of the push button from the digital pin. And LCD set structure means we set the cursor in the LCD display. If A is equal to 0, that means that we press the push button, and the count is less than 9 or equal 9, then count 1 is a variable will for the digit 1 will increase. If count 1 is greater than 9, it means that we press already 9, then again we press the button, then count 1 will be 0, and means that it will create a loop for the digit 1. And LCD print, we will print the count 1 variable and delay for the 3 second. No, 3 not 3 seconds, 0.3 second. And digit 2 and digit 3 is also same. This is the correct space function, correct password function. We set this cursor, then print the welcome, and again set the cursor in the second row and print the correct password. And digital write high mean that we turn on the LED and delay for the 2 seconds. Incorrect password means it is the function for the wrong password. Again we set the cursor and print the wrong message, set the cursor and print the attempt. And as the increment is in this loop, so we have to print the count plus 1. And in the for loop we blink the LED for the 3 times, so we use the for loop. In the digital write we make the LED or the error LED blink for the 3 times. And in the reset we again make the count all 3 0, and LCD everything will be the clear, and the digital row or the turn off the green light, and the set cursor in every place, and there make this in the predefined or the exactly the new place. And in the lock system we clear everything, set the cursor, print the lock message, and make the lock LED on, and delay for the 5 seconds. And after 5 seconds we again make the lock equal to 0. That means that lock system will the function will the code will out from the lock system, and make the LED also again 0, and counter means the attempt will be again 0, then reset press. This is the whole code, and I will upload everything to our project submission. Thanks for everyone for I think this video is become very long, but I try to explain everything in there.